All right, and so therefore in our WPS we specify that. It's a single V groove, complete joint penetration, single weld because it's welded from one side only, root opening 1/4 inch, root face none, it is beveled to a sharp edge, groove angle 45, and normally in a WPS you'll see a range. In this case we're not giving it a range simply because when we were looking at clause 4 and we went to the figures of clause 4 and we looked at the welder qualification test, it did not give us a range. It just simply said 1/4 inch root opening and then 45-degree groove angle. All right. So therefore, normally a WPS will have a range because you know, we don't live in a perfect world, and the fit up personnel are going to require to have some leeway. We're testing the welder in a with no back gouging. We're leaving the we're actually gonna remove the backing to inspect the root, but we're not going to back gouge in other words, the welder is not going to do the back gouging. That's not part of his test. The weld's going to be made on ASTM A36 hot roll plate because it is a low yield material that is going to have the elongation required to be able to do the bend test successfully and really be able to determine whether the welder has the skill level or not. We wouldn't make it difficult for a welder and give it with a give the welder a material that had a high yield unless we were required by contract. Let's say the customer wanted to test the welders tested on a higher yield steel. Otherwise, we don't, simply because when we look at D1.1 and we go back to clause 4, the tables in clause 4, that is, we're going to see that the welder qualification ranges table 4.12 for the essential variable changes allowed for a welder. There's nothing in there that dictates that he's only allowed to weld a particular type of steel. If he qualifies, the steel is not a restriction. If he qualifies on ASTM A36 hot roll plate, he's qualified to weld on any steel that is allowed to be welded by a D1.1 welding code. Okay, so there would be no reason to qualify a welder on a steel. For example, if we go back to table 3.1, we would not, it would be absurd to oops, there we go. So if we go to table 3.1, we want to test the welder on 1-inch plate, so we would use ASTM A36, but it would be thicker than 3/4 inches. Therefore, it would be a group 2 steel. It would have to be welded with a low hydrogen electrode, so that's fine. That's what we're doing. But it would make no sense to pick a steel like a group 4 steel that has to be welded with a 90,000 tensile strength electrode with a yield of 70 KSI. That would be absurd. You would not get the elongation required for that, and then your test jig would have to have a larger bend radius and so on and so forth. So you get into a whole ball of wax that you don't need to go. You just don't need to go there. When you test a welder, you just simply use a ductile steel like an ASTM A36. Qualify the welder. He's good to go for any steel under that code book. We do use the E7018 H4R. H4R means it has a really low hydrogen diffusible level. H4R means that the diffusible level of that electrode is, so we here have a 7018 H4R. That means that when we look at the deposit composition, has a diffusible hydrogen it's required to have no more than 4 milliliters per 100 grams of weld metal. In this case, Lincoln Electric gets the results of 2 to 3 milliliters. So they actually exceed that. They're able to produce a weld with very low hydrogen diffusible levels. If we looked at D1.1 and we were to go to preheat temperature table 3.3, oh, we got to admit somebody that just skipped out on us. Okay, hi, welcome back. If we were going to table 3.3 and minimum preheat and inner pass temperatures and category not A, not B, not C, if we were going to weld steels in preheat category D, well, look at that. We don't even have to preheat these. Does that mean that they're not important steels? It's quite the opposite. They're usually heat-treated steels that we don't want to preheat, and they're not subject to hydrogen cracking. And but the requirement is not just that we weld with a low hydrogen process, but now we're required to weld with a low hydrogen process that where the weld metal will not have a diffusible hydrogen level exceeding 8 milliliters per 100 grams of weld. And so it's pretty strict. As long as we produce a weld that has no more than 8 milliliters per 100 grams of weld, 8 milliliters that is of hydrogen diffused into the weld metal, then you can weld these category D steels without any preheating, as long as we keep we don't weld them below 32 degrees. Okay. And so now this is going back to the fact that H4R in a welding procedure actually exceeds that. So we could use this electrode to weld those steels of category D steels, preheat category D. So this is an F4 electrode because we looked at that table earlier, and an F4 qualified the welder for F4, 3, 2, and 1. Nothing higher than 4, but F5 electrode, although it's an SMAW electrode, it's a stainless steel SMAW electrode, and it wouldn't fall under the D1.1 structural welding code. It would fall under D1.6 structural welding code for stainless steel. No shielding gas used here. Preheat temperature, minimum 32. Usually here in California, we never see temperatures fall below that in our area, so we never have to preheat. In fact, actually, that should read 50 degrees if I'm not mistaken. So we may have to edit that, because when we go back to the preheat inner pass temperature, category B steels, A36, over 3/4 inches require 50. Yeah, a 50 degree minimum preheat, not a 32. If we were doing a 3/8 test plate, that would be only 32 required. We need 50. Nevertheless, we never fall anything. Pretty rare. It goes into the 40s here in our area in California. Sucks to be you up there in North Dakota, guys. I've been there, done that. Okay, for 10 years. So there's no PQR here because this is a pre-qualified welding procedure, and we should have written it was authorized by us, but it's okay. Welding process SMAW, it's a manual process. This is to be used for all positions. Electrical characteristics, there's no short circuiting or globular or anything like that because it's a manual process, but we do run it DC electrode positive. We're required to use a constant current power source. And so we like to add these things to make sure our WPS is specific. We require a stringer for the welder qualification purposes. It is a multi-pass weld. There's no contact tube to work distance. If we were going to do if we're going to do a wire flux core WPS, and let's say we're using the dual shield or ultra core gas shielded flux core wire, now we would go down to typical operating procedures, and we would see that there's a contact tube to work distance requirement here of 25 millimeters or 1 inch. So you got to maintain your copper contact tube to the actual steel plate. We need to maintain 1 inch. That will include the arc distance, the stick out, everything else. This is contact tip to work distance. So we put that in our WPS right here. contact tube to work distance. Not applicable because it's stick electrode. We don't allow peening. We don't really need to stress relieve by peening. Cleaning, you can grind or power brush, chip or slag. I guess a chipping hammer or a brush, hand brush would have been adequate as well. In this case, if this was going to be a welder qualification test for qualifying a welder for D1.5 bridge code, then it would not be allowed. The bridge code specifically requires that the welder could be qualified without the use of any power tools. D1.1 does not specify that. So this WPS is to be used for welding unlimited thickness welder qualification test coupon. Excuse me. So the welding procedure, and this is the old style of what WPS format. I seem to like it just fine. I don't mind the new format in the 2015 edition, but nevertheless, here we would be allowed by code to use 90 to 160, and so we put that in there. I wouldn't recommend that a welder that's testing would drop their 1/8 electrode, 1/8 7018 electrode down to 90 amps, or really to go to 160. But so we might want to narrow that down.
Yeah, I think we use the range.
Yeah, I'd rather keep it 10% up or down, but we're not required. It's still pre-qualified. We can use the full range recommended by the manufacturer. And if you remember when we were over here doing the Excalibur 7018, it actually allowed us from 90 to 160 amps for 1/8 inch electrode. And so, and according to the tables in D1.1, we're allowed to use that's table 3.6. Where is that? Right here. So the maximum current can be within the range recommended by the filler metal manufacturer for pre-qualified WPS. So I think that's the reason we did that. We would tell the welder, don't be crazy, don't turn it up to 160 because you're going to do yourself a world of hurt. Nevertheless, he can run the root and the fill passes with the E7018 1/8 inch. The cap pass, has a choice of 3/32 or 1/8, and then he can run a 3/32 70 to 110 inches, or I'm saying amps. No volts can be placed here because the welder has no control of the voltage. The voltage is only going to vary according to the arc length in a constant current machine. Remember that we put a constant current machine was to be used here, which means the volts are automatically adjusted by the machine depending on how the welder holds the arc. If a short arc is being produced, then the machine would drop the voltage so that we don't get an excess amperage going across the arc. If the welder decides to long arc it, then the machine will turn up the voltage automatically to be able to get that many amps across the arc. A longer arc produces more resistance. All right, so the travel speed is going to be more or less suggested, but on average 6 to 10 inches per minute is adequate. We kind of got to narrow down that a 7018 1/8 inch electrode will produce about 6 inches of weld, and it would take about a little over an inch to a little bit over a minute to consume that electrode, maybe a minute and 15 seconds or a minute and 10 seconds, depending on the amperage. So 6 to 10 inches per minute. If the welder was to run 160 amps, he would never be able to get 6 inches per minute. He'd be lucky to, he would actually get more than 6 inches per minute, but the weld wouldn't be very adequate. So anyways, that's just kind of something that we average from what we see in the actual welds that we make when we do demos and so on, right? So the second page, I like it because I could put the image of the joint sketch right here, but then it would crowd me out, and I would have a little tiny space to put the image, and sometimes I have to put a lot more information on that joint sketch area. So I'm going to do this, and I'm going to put the dimensions again in here Normally I would have tolerances here for a production weld, but for a test coupon, we put none, no tolerance whatsoever on the root opening or on the, if there was a root face, on the root face or on the groove angle. If this was a production WPS for this exact same butt joint, single V groove, we would go to the pre-qualified figures of 3.3, and then I would use those tolerances in there, right? I would have the tolerances up here, and the WPS. I would not include a detailed tolerance. I could, for example, go to my WPS for production. Instead of putting a 1/4 inch root opening, I could already in here detail it as add the 1/16 of an inch that is given to the detailer, right? So instead of that 0.25, I would go 1/4 inch plus 1/16. That would give me a 5/16 root opening. And then I would add the 1/4 inch and plus or minus the 16 fit up tolerances. I could detail it as I wish with that 16th tolerance that it's allowed for me to use. And then the fit up tolerances here would be, plus or minus, plus 1/4 and minus the 16th and so on. In the case for a weld test coupon, we go, nope, no sir, you're not allowed any tolerances because clause 4 has a joint sketch and it does not allow to deviate. Okay, so then I certify my WPS, even if they are pre-qualified. I certify them stating that these in fact conform to code, and I date them and sign this is how we submit them to the AWS certification department. This is how we submitted them when we applied to become an accredited testing facility. So we are a California Welding Institute is an AWS accredited testing facility. It means that all of the welders we qualify here, we can send a copy of the test record to AWS, and they keep that record on file, and the welder can maintain their welder certification through AWS directly after they leave here. All right, so I think what we want to do is go back to pages, and so we went through the 7. We did examples of WPSs. We didn't exactly do T-lap and corners, but we did the V groove, the CJP groove weld. We looked at beam to column moment connections, and we also did a CJP, which we had anticipated doing that, but we didn't get a chance to write it down here. We did the single V groove, and for welder qualification purposes. So I pretty much think that wraps it up. I can't think of when you're preparing WPSs for a contractor or for your testing lab that we haven't addressed all the things that you need to keep in mind and go over. So I'm going to leave the floor open to questions right now before we conclude the session. And I do got to use the restroom real quick, so I'll leave Marianne in charge. Okay.
If you have questions, you can write them in the chat, or I think you can still unmute yourself. Okay,
All right, I'm back.
we have a question
All right.
here.
Can we review what D1.1 specifies recording interpass?
Regarding
Regarding interpass cleaning for welder qualification tests. Actually, when you're qualifying a welder, there is no requirements. Let's go to D1.1 here. If we were going to go to clause 4 qualification, let's go to part B, welder qualification, part C, performance, right? There's really no requirement for the welder to do it with or without tools or any kind of requirement for interpass cleaning. And so performance qualification tests required by code, specifically device tests to determine a welder operator's tack welder's ability to produce sound welds. Qualification tests are not intended to be used as guides for welding, tack welding during construction. The latter shall be performed in conformance with the WPS. But when it comes to telling you how to make the test, it really doesn't give you any requirements. For example, the bridge code does. D1.5 specifically states that the welder has to perform the welder qualification performance test without the use of power tools. Okay. In this case, it doesn't. So what we have to say is, because here none of these clauses make any reference to interpass cleaning, we have to by default go to clause 5, fabrication, and we go to the end of clause 5, whoop, right there, and weld cleaning, okay? And we have to use what is required for production in fabrication. In process cleaning before welding over previously deposited weld metal, all slag shall be removed and the weld and adjacent base metal shall be cleaned by brushing or other suitable means. This requirement shall apply not only to successive layers but also to successive beads and to the crater area when welding is resumed after interruption. So in other words, if you run out of rod, you got to chip the crater before restarting a rod. It shall not, however, restrict the welding of plug and slot welds in conformance with 524. So it really doesn't say anything whether you can or cannot use a grinder in between passes. Of course, there's no reason why not, because it's not prohibited. Now, one thing we got to consider is when we go to weld repairs, okay, repairing a defective weld. And this is what happens in process sometimes when in a multi-pass groove weld, for example, including in a welder qualification test. Welder is going to run a 3G and it's running a vertical bead and it just gets a little lumpy. And so before he continues with a successive layers over that, he or she may want to grind down a lumpy start or whatever it may be. And that there's no reason why it couldn't. Now, we got to keep in mind that it's under repairs here in clause 5, it says that the removal of any weld metal or portion of the base metal may be done by machining, grinding, chipping, or gouging. It shall be done in such manner that adjacent weld metal or base metal is not nicked or gouged. So for that reason right here, when we qualify welders, if the welder got a little carried away, careless, and took the grinder for a walk in the woods, then you know, he nicked or gouged the test coupon outside the weld area where he was going to weld over it. Then he's disqualified. He or she is disqualified. And so we're pretty picky about that. We're pretty picky about arc strikes too, because arc strikes require repair. So if we look at clause 5 here, arc strike, they're required to be repaired and check for soundness. So wait a minute. So if a guy in a test, you know, he strikes an arc somewhere, is he going to grind and smoothen it out and repair it? And then we're going to have to check for soundness. Well, that's not going to happen, because that means that there was a reject and a repair required and an inspection required before and after the repair. And so that, you know, there's no second chances in a test that would disqualify the welder if there was an arc strike on that test. Okay, so there's nothing strictly written in black and white about these things, but if you put 2 and 2 together, by default, you're gonna think that, oh, okay, I get it. You know, we're not gonna allow the welder to. We're gonna allow the welder to use a grinder if he wants to, but we're not gonna allow the welder to nick or gouge a base metal. The other thing that we don't allow is, let's say that they do a cap pass or a cover pass, and it exceeded an 1/8 inch of weld reinforcement, and then, well, they can remove it and re-weld it, but they cannot just fix it by grinding, because we have to be able to do a visual inspection on the as welded test coupon. It can't be modified or repaired by grinding to pass a test, you know, because then, you know, what we joke about is we'll give that guy a grinder certification, but not a welder certification. Okay. And so the other thing that a lot of people that test welders out there are not doing right is, if we go to clause 4 and we go to the requirements for the visual inspection of a test coupon. This is, we're referenced back to, no, it's, hold on a minute. Nope, I'm going to be right here. Hold on. 4.9, there it is. How we test the test coupon. And this says for WPS, but baloney, because when we go to part C down here, performance qualification, it just references us back to 4.9. So this is for WPS and for welder qualification as well. We do a visual inspection on that weld test coupon right here in 4911. And so you check for cracks. I've never in my life seen a crack on a test coupon, unless it was a very large test coupon and we were qualifying a WPS. But if we're qualifying a welder, a crack is totally unusual. But craters are sometimes, and they leave underfill, and those have to be filled to the full cross section of the weld, so that that can be determined when doing a visual inspection. The weld reinforcement shall not exceed 1/8 of an inch, and the weld profile conform to 5.4. So the weld reinforcement not exceed 1/8 inch. Well, we use a gauge, and it's pretty easy to tell. If it exceeds an 1/8 inch, the welder fails. If they can detect that themselves, if they're trained to inspect their own welds and they see that their cap pass exceeds 1/8 inch, they can remove, re-weld it while in progress or while in process. But the finished product cannot be modified to not exceed 1/8 inch by grinding, because then he did not demonstrate the skills of welding. Undercut is allowed, but no deeper than 32nd. And here's the deal that I'm trying to get to. The number 5 item in the visual inspection of the weld test coupon, it calls out for the weld root to be inspected for all CJP groove welds. And so if we were to go, so keep that in mind, that the weld root for CJP groove weld shall be inspected, not have any cracks, incomplete fusion, or inadequate joint penetration. So if we were to look at the test coupon, and how are you going to inspect the weld root if you have a steel backing? Well, you can't. So most people think that you inspect the root pass from this side. So if I'm testing a welder on pipe, I want to ask you, and the inspector wants to inspect the root, is he looking inside the pipe or outside the pipe? Obviously, he's looking inside the pipe. And so inside the pipe would mean that we need to go to the root side and inspect. Problem is, we have a backing in the way. Well, that's not a problem. We remove it. And then we inspect the fusion to the corners of both of these members being welded, and there cannot be any lack of fusion or any cracks or any inadequate joint penetration. If we don't remove that steel backing, we simply did not do our job, and we did not conform to code, because we did not visually inspect in accordance to 4.9. And I find that probably the 99.99999% of the testing officials out there are not removing the entire backing entirely and grinding the backside smooth to inspect the weld root. Okay, the weld root is not the root bead, it is a weld root. There's a difference. And you can go to AWS A3.0 for definition. It'll clearly tell you the weld root is on the root side, on the back side of the joint. In a double welded joint, it is in the center. With a weld root, you would have to inspect it from the second side. Okay, so now that doesn't have anything to do with the WPSs. But it kind of, if you're writing a WPS like we did here for the purpose of qualifying welders, like we stated there, then you need to make sure that you remove that backing and inspect the weld root from the root side, not from the front side. That is just merely looking at the root bead, not the weld root. Okay. All right. So what else we got out there? I kept wondering if it was the autogenously welded bike frame that failed and caused the injury. Yeah, it did, because when that neck was welded to the frame was welded to the neck tube without filler metal, what happened is basically kind of much what happens here in this lap joint here in figure 2.1 design. If we look, what happens here is, so this is a lap joint, the neck and the frame come together, and the welder put a weld in there. And instead of adding filler metal here and creating a filler weld throat that was adequate to transfer the load from the frame to the neck or the neck to the frame, the welder merely took the metal in the corner here of the lap joint and melted it down. And by doing that, GTAW notoriously does not have deep penetration. And so especially on thin material where you have to weld with low amps. So if you melt this top edge here and bring it down to the member that this piece is lapping onto, you're just not going to get the weld throat that is required to transfer loads from the neck to the frame of the bicycle. And absolutely, that it wasn't so much because it was autogenous, but the fact that it was autogenous, it lacked filler metal, and so it lacked the ability to fill in that corner and produce a sufficient weld throat where the loads could be transferred from one member to the next, So yeah, absolutely. Next question says, can you explain number 6 of visual inspection without backup bars? Yeah, absolutely. So we are in D1.1. We're going to go to part B, qualification, and we're going to go to 4.9. So what it says here is number 6, for CJP groove welds is welded from one side without backing, then the root concavity or melt through shall conform to the following. So if we're using like say we're doing a V groove, but without a backing, we're doing a BU2 instead of a BU2A. That means we're going to have a root face and we're going to have some melt through, hopefully. Then, but it says here, welded from without one side without backing, then the root concavity, meaning if it's a suckback or the weld root was had any type of concavity in it, or if the melt through, meaning the penetration exceeded the maximum. Okay, so the 6A is the maximum root concavity, not to be any more than a 16th inch deep, as long as you had at least a 16th inch reinforcement on the other side. Okay, so the weld thickness has to be provided. So if we're welding on 1 inch thick metal and we have a 16th inch concavity on the root, there has to be at least a 1/16th reinforcement on the front side of the weld. And then the maximum melt through has to be not to exceed an 1/8 inch. So that goes back to the same as the weld reinforcement on the front side of the weld. Now, this used to continue for TYK connections and so on. That was carried over to class 9. If you're looking at a 2010 D1.1, then there'll be the additional for CJP, for TYK connections and so on. And right now that would be in clause 9. So let's see, does this apply to pipe and tube only? No, this applies for a, look, remember, this is a WPS qualification. So can we actually qualify a procedure without a backing and without back gouging or back weld? Yes, we can. That's why it's just simply not pre-qualified, but nowhere in this code book said that it said that it was prohibited. So we can actually qualify a welding procedure with an open root without back gouging and back welding, as long as it is qualified by testing. So this would apply for pipe also, but for plate as well. If we were trying to qualify this procedure without a backing and without having to back gouge and back weld, then we have to consider A and B and number 6. And so where this comes from is, let me think, I believe fabrication for tubular structures, I got to think a little bit. There's a place where it says that there are no pre-qualified procedures for tubular structures for open root without a backing. I may have a little bit of problem trying to think of where I saw that. It could be in clause 4, I believe. Now, because we're at the end here, so let's go back to clause 4 in part B, or even in part A, possibly. General requirements. No, well, I know where it is, duh. Clause 9. Okay, so I'm a little bit too used to, I'm too used to, what do you call it? I'm used to the 2010 a lot, where everything was all in one place. And so now it's not. Pre-qualification of WPSs for CJP groove weld requirements. Non-pre-qualified joint details. There are no pre-qualified joint details for CJP groove welds in butt joint made from one side without backing. Okay, so it is not pre-qualified. You would have to qualify by testing. If you want to do a butt joint on a tubular structure, whether it be a round tube or pipe, or whether it be a box tubing, you want to do a butt joint and not have to use a backing, but you can't get in there to back gouge and back weld. So therefore, you have to qualify by testing. And I remember seeing this together in clause 4 back then in 2010. And so sometimes I'm still getting used to 2015. I don't know what I'm going to do when 2020 comes out. When I start using 2020, it's already out. And I do already have it as PDF. I haven't reviewed it yet. But I swear 2020 is going to be a pile of work, because they have completely just blown all the numbering of clauses and tables and figures totally different, totally out of proportion. And it's going to take a while for me to remember all of that. All right. So it was in clause 9. That's why I couldn't figure it out. And what happens here, there's no pre-qualified joint details in butt joints made without backing. Now, the thing of it is, the backing gets a whole ball of wax here in clause 9, and I'm not going to get into it, but when it gets into cyclically loaded structures, then it becomes problematic, because you can't use the backing, because you can't get in there to remove it. So you have to qualify the procedure without a backing. Okay. All right. Well, thanks so much. You guys have a wonderful